Okay, so for this video and the next, I'm going to keep referring back to this example. So I've called it example A. And so whenever I'm talking about example A, we should go back here. And so this example is saying that all 100 employees of a company were asked whether or not they are in favor of or against working 4 days a week instead of 5. And so it gives us a table down here. And this table is an example of what's called a contingency table. And so a contingency table basically just relates to different categories of information. So this is one category, this is the gender, and this is the other category, which is their opinion. Oops. And so whenever you're given a contingency table like this, if you're not given the totals, that's the first thing you should do is find the totals. And so here, 19 people were in favor. Against would be 1181. I think that's right. Yeah, because this should equal 100, right? Because it says all 100, so the total number of people should be the same as the total, or it is the total. Okay, and so here, there was 40 females in the company, which means there's 60 males in the company. So, yeah, we have 60 males, 40 females, 19 in favor, and 81 against. I would imagine these 81 people said no, because working 4 days a week usually means you work 10 hours instead of 8. But okay, so here, the first question says, suppose one employee is selected at random from all of them. Find the probabilities for each simple event. And so if you scroll up here, I talk about the difference between simple and compound events. And so an event that includes only one outcome is a simple event. And so here, the simple events would be these 4 things: male, female, in favor, and against, right? So those are the simple events that nothing else is going on. And so here you have probability male. And so I'm just going to use that relative frequency rule that we had talked about last class meeting. And so you have 60 males over 100 total employees. And so here you have 0.6. Next, I'm going to find probability female. And so here I'm going to get 40 out of 100, which is 0.4. Probability that somebody is in favor is going to be 19 over 100, which is 0.19. And then probability that somebody is against is going to be 81 over 100, which is equal to 0.81. For these next 2 examples, I used that shorthand notation where instead of writing out in favor, I put I, and instead of writing out male, I put M. And so here this one is asking us to find the probability that one person is both in favor and is a male, right? And so here, what you want to do, so this is going to equal the number of people that are both in favor and male. So I'm going to use the shorthand again. And I'm still going to divide it by the total, right? Because I'm choosing out of everybody what's the probability that one of them is both in favor and male. And when you're given a contingency table, and so later on, when you see the word and, we're going to have a formula for solving these. But when you're given the contingency table, what you can do is just look at the intersection. So I'm going to kind of highlight the column. So how many people are in favor? How many people are male? And the number I care about for this numerator right here is the number that's common to both of them. And so that 15. And so what I'm going to have is I'm going to have 15 divided by 100. And so this is equal to 0.15. So there's about a 15% chance that one person out of all 100 of those people is both in favor and male is 0.15 or 15%. This is asking for something very similar. So number of people that are both female and against, and I'm still going to divide it by the total. And so here, rather than looking at these two columns, I'm going to look at how many people are against versus how many people were female, and the number I care about this time is 36. And so I'm getting 36 divided by 100, which is equal to 0.36.